congratulate you because it seemed like it was as early 1993, 1995, having conversations with Terry about industry, and there was a complete pushback. So I mean, this has happened very rapidly, and I think you guys have been leaders. So congratulations.
Thank you.
So can I make just one other quick point? I mean, there are most unfortunately. Because the full industrial picture must include this. Most unfortunately, with respect to sustainability, we have a considerable number of everyday chemicals that are potent endocrine disruptors and are not compatible with a sustainable future. And those are pretty much off the table at the professional meetings as things that you can talk about. Unfortunately, if we're going to have a sustainable future, we have to talk about them and we have to do something about them.
Jeremy, and then Claire.
Okay, Jeremy Jackson, Smithsonian Institution, recently Scripps Oceanography. You talk a lot about toxicology, and I'm with you, and I think I've read a little bit of the literature that inspired all this, but I'm an ecologist. And so, I mean, it's one thing to talk about poisons in the environment, but it's another thing to talk about the way we change, I'll call, for want of a better word, the balance of nature in ways that might not be toxic, but which have profound effects. The most obvious one for me as a ocean biologist is the consequence of using certain kinds of fertilizers, which utterly change the balance of power in aquatic ecosystems in terms of what wins and loses. And so I'm curious, because I think the toxicology course is an incredible step in the right direction, but I worry that most toxicology courses have about as much environmental biology and ecology as most chemistry courses traditionally have toxicology. And if you think about going all the way back to Silent Spring, of course, the whole issue and greatness of that book was the balance of ecological perspective with an understanding of toxicological consequences. I don't think you can separate them, but I realize it's also a huge challenge. I mean, the GMO people will not talk about this, right?
I think you make an excellent point and actually illustrated it. For whatever reason, people hear toxicology and latch onto that. But what did I actually say? I said a course in toxicology and a course in environmental mechanisms of harm. I actually said that, but everyone heard toxicology.
Including me.
Right. And but the 12 principles of green chemistry unequivocally include all kinds of hazard, from human health to the environment, of things that are immediate, things that are persistent, and things that are long range. There is no segregation, and true training must recognize all of those things. It's just that for obvious reasons of human self-interest, we hear toxicology first and latch onto it. But green chemistry is not about toxicology. It is about energy use. It is about renewable feedstocks. It is about human toxicology. It's about environmental issues. It's about global issues. There are 12 principles that span pretty much everything you can imagine. I think you'll find nothing missing.
But just to clarify and sort of play devil's advocate, I mean, there's still just this sort of one course one has to do. I mean, it's an incredibly neat challenge that you're talking about. And I'm just thinking about the way I know some of these things are taught in academia, which is way behind the curve in all of these things. I mean, do you have some sort of vision of this becoming part of the broader environmental curriculum and program writ large in academic settings? Because, I mean, we really need those chemists to be going and participating in the other aspects of environmental biology if we're going to. I mean, is that doable?
Well, again, the course that was just taught at Simmons this last year is called Mechanistic Toxicology and Environmental Health Sciences. All right, and again, it's hard. One of the problems, and it comes back to the enemy of the excellent is the perfect. Once we say we're going to try to move the ball forward with chemistry, everyone in the room is going to think, well, it has to have this, it's going to have that, and probably about third row down, we'll have to say, all right, forget it, we can't do it anymore because everyone wants something in it. We've got to start somewhere. All right, and I agree that it's not going to be perfect what we do first. It won't be perfect what we do second, and we're going to need everyone in society to participate to make sure that we revise it and make it better.
And I will say, having participated in the last several years in an effort to build bridges between two very different disciplines, chemistry and environmental health sciences, that there are serious challenges, but there are huge rewards. As you know, Jeremy, the most interesting stuff scientifically happens at the intersections of disciplines. But academia is not prepared to deal with them. It's a struggle. But this sort of effort we're engaged in today, that we're describing here today, is one that will help, I think, move the fields overall. Let me ask, I know Claire has a question. We could turn the microphone to you.
My name's Claire Dwoskin, and I have a family foundation. And our foundation is funding independent scientific research into toxicology, and specifically mechanisms of toxicology in pediatric populations. So I do like science and chemistry, and one of the things we're finding, we've sort of assembled a loose consortium of scientists, multidisciplinary scientists looking at some of these issues, and that there really isn't a very safe environment for scientists who are looking at toxicology and mechanisms, and because it might be impacting somebody's, there's a little bit more of a tilt toward the business end of things rather than the impacts on the population. And so scientists find that they're under attack sometimes when they do research looking at mechanisms of toxicity in pediatric populations. So what is any of the scientific leadership doing in terms of trying to help create a safe environment for this type of research? And I really appreciate your comments and your speech.
I'm going to take the first crack at that because I live directly in that world, not pediatric issues, but endocrine disruption, and that issue has met a fierce resistance that has involved, not to me personally, but has involved physical threats, it's involved bribes. It's been a very uncomfortable zone to be in. I think given now that it's no longer fringe, there are mainstream institutions that are acknowledging that it's real. There are also companies that are realizing they can make a profit off of producing materials that avoid health problems like that. It's changing. But one of the interesting things that has emerged in this is, at least within that community, there's a sense, and there are hundreds of scientists in this community. There's a sense that they have each other's back because they've met such fierce resistance. And there are actually mechanisms that have been developed to make that mutual protection work better, and I'd be happy to talk with you about it off channel.
Can I pick up on this? Because actually, Claire, you touch on a very critical point. And the question is, as we go out into the future, how is it going to be different? We have the most amazing scholarship on intimidation of scientists, etc., throughout the 19th century. And I believe this should be taught to chemists, and I teach it to chemists. And so Jerry Markowitz and David Rosner's outstanding book, Deceit and Denial, which deals with problems of the lead and the chlorine industry, is taught at Carnegie Mellon. The students read the book, and then they write essays about the impact of the information in the book on them. These essays are incendiary. I grade them all myself. And I think that once people see how the unfair pursuit of money in the face of a very deadly toxicant that is impacting the entire population, once they see that, and they see because these books are written based on disclosure, and the historians got hundreds of thousands of papers of the lead and chlorine industry, and you hear the people talking through that exercise. Now, I think we're in a different place today, and it's really good, but we never want to be in that place again, and teaching it is the best way to neutralize it.
So we have time for one more question, and I'm going to ask board member Stan Bearer to ask the question.
Thank you. Great presentation. I'm a lawyer by training, and I really related to your comment about in high school hating chemistry. In fact, I felt that way about most courses.
Me too. Yeah, that's why I'm a musician.
And my chemical experience is basically how much vermouth to put in a martini. One thing I do have some experience with, I spent close to a decade as a regent at a great research university, the University of Washington. And I'm very aware of problems in academia and the silo effect of each department. So when you talk about creating a greater awareness, a greater educational demand for green chemistry, I would make a suggestion as someone who's familiar with how universities work. I wonder if someone getting a PhD in economics is required in their benefit risk analysis, teaching and learning to assess toxic risk as part of cost benefit. Does a dentist or a physician student or a public health official to become licensed have to learn about toxicology in order to be licensed? Does a landscape architect, to be licensed, have to take a course and be trained in what chemicals can be used in a garden? Does a veterinarian, to get a license, have to learn about what can be given to an animal that may ultimately not only injure that animal, be passed on to a human being? When a Public Utility Commission is faced with the rate increase question, should they have to consider whether a utility is offering a more dangerous toxicology form of energy than a non-toxic? My point is, the way to create your demand for your type of brilliant work is to make other professions and other schools dependent on such education. For example, you could also say, should the Securities and Exchange Commission put at risk directors of public corporations who authorize a new project or a new product without doing due diligence on its toxicology? My point is, it's hard to break the silos in a university unless each of those silos is required to know what you're doing. Have you pursued that at all?
I know several places where several of those things are being pursued, but no comprehensive effort. And I would turn to Terry, who's most experienced in academia.
So Stan, that is just the most beautiful question, and the most perfect analysis directionally of what we've got to do. We will never have a sustainable civilization unless health and the environment are integral value components of the value proposition, which is exactly what you're reflecting on. And so I think the green chemists are way ahead of, I think we really are way ahead of a lot of our other disciplines, and we need them. We need our friends in these other disciplines to join with us. And you hit the first one you hit is the really critical one to start with anyway, and that's economics. And there is some brilliant work being done in economics, but it needs to become absolutely integral. And so my vision of a university of the future has sustainability taught in every department. And the thought of countries going underwater is an integral part of the discussion of the value of any energy thing, just as you pointed out with that question. So thank you very much for that. That's awesomely prescient of you.
And with that optimistic end and note, I want to thank all of you for staying here these couple of hours with us, learning about the power and potential of green chemistry, and I especially want to thank John and Terry for brilliant presentations.